So, I guess we're going to start. It's 10 o'clock already. So, to me, cooking is something like an essential skill you have to have. I just wish someone would have told this to my younger self, and that's actually me at the age of 18. I'm Chris, by the way, and I work for Broadcom at the Spring Data team. And at that age, I still remember moving out of my parents' home into my own flat, being on my own. I was really excited. I was proud to learn all the new stuff, and I was excited because I went studying, studying, and I really studied hard at that time. But you know, when you're studying, you don't have that much time for, let's say, preparing a meal. So at that time, my nutrition was based on instant soups. I could handle those. I could also do perfect instant noodles, and I had a microwave, so pizza fresh out of the microwave. That was just the thing for me. But you can imagine it was not the healthiest way, and it was also quite expensive when you had to order meals. I mean, the flip side is you could do with the packaging, you could have a little fun. So after all, since it was expensive and I was studying, I had to find a way out of this. And one way forward for me was to try out spice mixtures and compose them myself and experiment with the ready sauce. But that didn't do the trick for me in the long run, because it just didn't, it always tasted the same and it wasn't the experience I was used to. So in the end, it turned out I had to swallow my pride and go back to my parents' home and ask my dad for some cooking lessons, because in his previous life he had been a chef before he chose another career path, and so he taught me the basics about cooking and what I needed to know, like explain the terms and stuff like that to me. So, and in the end, it turned out I, over the years, improved my cooking skills so that by now I even can prepare a meal that my kids would eat, sometimes at least. So I count that as a success. And during the preparation of this talk, I found this quote from a French chef, which basically tells us that we should work towards something where we use as little ingredients as possible to create something that is serves our needs and even tastes great. And back in the days when I was trying to cook, I just poured in every ingredient I could find, because the more spices I put into my dish, the better it would taste. And I think this was a mistake, definitely, because fewer ingredients and just it gives the ingredients you put in the natural flavor. And I think this is very true also for software that we create, because there is so many things we can put into our, let's say, persistence layer, just because we can, but we don't necessarily need. So we drown within the API that we create, and potentially even create the next kitchen sink, while we should aim for just creating a minimal surface that we want to expose to our consumers. And this is what this talk is going to be about. What are the terms we're talking about when we talk about persistence with Spring Data? We will talk about how can we structure our code and design our repositories so that they fit the needs of our customers and our consumers, but also make ourselves proud in some way that we crafted something that we think is good and that we can like and live with. Right, so before we really dive into the specific recipes, I think it's necessary that we go over a few terms that that we use in our daily work. Like, there is a domain type. And then when we speak of a domain type in the terms of a Spring Data repository, then it's basically any type within a given problem scope. It doesn't have to be a managed entity if you're speaking in terms of JPA, but it's just any type that you have in there. Then we have this term of an aggregate root, and you can think of an aggregate root as a cluster of domain types that logically belong together, and by just pulling the aggregate root, you get all the dependencies along with it. Next would be the repository, which is our main entry point to a persistent collection of aggregate roots. So like if you think in terms of an order and line items, then the order would be the entry point, and it will pull along the line items, which are domain types, though the order would be the aggregate root. Custom implementations, you can do those, add those. Those are extension points to Spring Data repositories that you can do on your own when the functionality that the repository offers you isn't enough for whatever reason. A projection is something, is like a view, an isolated view upon an aggregate root, where you can pick and choose those properties and attributes that matter to you the most. Those don't necessarily have to be managed entities, not at all. It can be just anything, but we'll get to that a little later. And the template API, which is something that is more common to the NoSQL stores, where those are the components responsible for managing all the resources and the transaction handling, so that you don't have to bother about this. Those are typically more low-level APIs and not the high-level ones, and are pretty close to what normally the drivers for the data stores offer you. Right, so now that we've finished the terms that we're going to use, let's dive into our first recipe, and that's a pretty simple one. Like the pancakes, you just take eggs, flour, a little milk, stir it up, pour it into a pan, and then just stack them up layer by layer, and then you get this sweet, tasty dish. And we can do pretty much the same with our code and the way we structure our code. And I want to go quickly back to this order that I've been talking about before. Like pretty much everyone knows the order, and the order has line items and maybe related to a customer. And we already can begin to structure our code by creating semantically aligned entities by just nesting the line item within. Does that actually work? Yes. The line item within the order itself, so that it's not the top level entity, but we really get the connection that the line item itself won't live without the order. And the order can have an ID and obviously a status and stuff like that. And within our structure, we can also leverage the way we structure our code in packages. And this is not only true if you're building the next modular monolith, like the Cora is explaining in the other session, but it's also true for a microservices. So we really need to think about how we align those aggregates roots. We can even, if we follow this layout, like the order and the inventory, we can also just put in the repository within the order package and keep everything in there, and try to only expose a minimal surface. So since we have an order management component over there, that one should be the main entry point for everything that comes from outside. So the order repository itself wouldn't have to be public, sorry. It just could live within the package, and the Spring Data infrastructure would just create it for you and inject it everywhere. So that would work just fine. And speaking of repositories, I think everybody knows the outline of the Spring Data repository. I just put it up on the slide here real quick. So we have the top level repository, which is just the marker interface. And then we get different variations predefined with predefined methods like the CRUD repository, which has save, delete, find all methods and whatnot, returning iterables. We'll get to that a little later, why they are returning iterables, but that's the way it is. And because iterables are not really nice to work with, we also have variations like a list CRUD repository that just overrides the method signature so that you can work with lists instead of the iterables. And typically, and this is true for most of the stores, we have a store-specific repository abstractions that contains specific methods unique to the technology you're using, like the JPA repository offers you a flush method that you wouldn't want to that you will not see in the CRUD repository because MongoDB doesn't know what to do with the flush. And next to the CRUD repository and all the list stuff, we have paging and sorting repository. Since they're interfaces, you can compose them nicely, which brings in paging and sorting capabilities into your repository. So, if we think about this minimal approach I've been talking about before, then we could also structure our repository a little bit differently. Like, we could pull in CRUD or we could let order repository extend CRUD repository. But in doing so, we'd also inherit all the methods. Like, what if we only wanted to save an order, but we wouldn't want to expose the delete method? Because we would never want to delete an order, but just set the status to cancel or something like that. So we want to keep track of each and every order that ever passed our system. So in that case, why would we want to do it? We can perfectly fine live without CRUD repository every time, because by just the way Spring Data repositories work, we are perfectly fine if you just go in here and add the method signature from one of the predefined repositories to your repository and be done with it. Just because the data proxy that we build around the interface will just recognize that there is already a pre-implemented method that matches the signature, and it will just invoke those. So in doing so, we just prevent outside callers from deleting orders by accident. And it will be it's more secure in some way because a method that isn't there cannot be called. So this is an improvement. Also, there is you can also use the derived finders, which is the way Spring Data helps you build those everyday boring lookup methods by just you put in the method name, we chunk it up, we determine what you want to do, and then just run the query for you. And of course, you can also pull in different methods, like we want to get an order by its ID. So there is in the CRUD repository there would be something like find by ID. If you don't like the find keyword, no problem. Just use something like get by ID. So this is there is a couple of keywords that you can use to express your needs. So it could also be fetch or something like that. So those are all documented, but you can fit it to your needs. And one thing that we as the data team try to avoid is we try to avoid to leak those store specifics like an entity manager flush into the actual domain, because the repository should abstract you from the technology that is underneath, and you don't want to deal with that at that point. So reconsidering the decision to add flush to the JPA repository, I don't know if we would want to do it again, but that's more of an internal discussion that we're having in the team. Right, so for completeness, this is something, this is how the order management could look like. it would use the package private repository and then just do some verification so that there are no duplicates, or once the order is completed, it checks that the payment has come in before and stuff like that. So this is the component you would want to interact with. Now, if you think of more advanced capabilities, like an order could be delayed and you need to find out which orders are delayed so that they get a higher priority and are executed faster, you could also decide to, this is JPA specific, bring in additional functionality. Like for JPA, we have a component that is called the JPA specification executor that helps you build up criteria queries and then just plug them into the repository. So this is like a shortcut that you can take if you happen to have more advanced queries that you don't want to express as a plain string, maybe because most of the stores have some sort of add query annotation, and you can bring in a GPQL query or maybe a MongoDB BSON document, whatever you to just run the query. But this is also, there's alternatives that can help you bring in more advanced capabilities into the repository. And again, the thing is, you don't have to explicitly extend the JPA specification executor, which has all this bunch of methods right here. And see, there is the delete method again that we explicitly didn't want to have. So you can just pull up the interface, the method signature into your repository interface and be done with it. And some people might already have noticed that in this example, I'm not even using the repository marker annotation right there. So in some cases, you don't want to buy into, let's say, the Spring types and the signatures they bring with them, because at some point we may want to change them, and this will potentially break your code. So, or there are some company restrictions that you may not extend types from other libraries. Then you can just non-intrusively use the add repository definition annotation, and this will also tell our infrastructure, wait, there is a Spring Data repository, and we need to create one for you. So this works perfectly fine, and is just an alternative way for you to create your repositories. All right, so those are the basics. Now that we've set the basics, we can maybe spice up our dishes a little bit, and one way is by adding sauce and dips to a dish. And the good thing about sauces is that you can make a lot of them and then just put them in the fridge and use them later on. So really nice. So if we have our repositories, and just for a moment, imagine that we're following this minimalistic approach. So we're not extending the CRUD repository to get our stuff done. And right, so we have the order repository. Now in our domain, we might have customers and inventory. And then all of a sudden we recognize that we are going to repeat the very same pattern over and over again. Just because we have this get by ID and we have this save method. And we could think, yeah, well, then let's go back to just pulling CRUD repository and be done with it again. And no, you actually don't have to do that. You can do it differently. So there is ways you can define your own custom base repository and just use it and tailor it to your needs and your domain. So one way to do is you can extend the repository interface to just tell it this is going to be a repository, and then copy over a generic signature in this case. And the crucial part is you have to define it as no repository bean, because otherwise our infrastructure would just recognize repository and try to do its stuff, and it would fail. So you mark it as no repository bean, and then hello. Right? And then just take it, extend it, add your domain types, and be done. And you can do this for all the customer repository and orders and inventory that you have. Another way would be, and this is again a less intrusive way, is just define the customer repository. Again, just as a plain interface, no Spring dependencies in there. Add it, and the only downside that you'd have is you'd have to repeat the domain types, just because you have to tell the infrastructure, hey, this is a repository, and the other one is this is my base repository, and I want to pull in all those methods. Right there. So another thing that you could do, and this is very store specific. I just picked JPA because it's one of the most popular store implementations that we have out there. There is a bunch of store specific annotations that you could use and add to your repository methods. It's like pretty much every store has support for index hints or fetch sizes, or lets you add comments to the queries that are run against the database so that you can then go find them if there is a performance problem, and identify the query within the database logs. Or you can tell it how to load certain things, like with an entity graph in data JPA. That's a nice way. It's also non-intrusive because, you know, if the library is not there and the annotations, they just don't get evaluated. So pretty straightforward way of extending your repository. Right. Now that we have dips, we can actually create our main courses, and barbecue is something that is very special in my place, at least, because I live in Austria, and barbecue, you normally just do it in summer and people get together and I can start the fire, and that is something that I love about barbecues. But for our Spring Data barbecue, we're going to talk about repository return types. So there's different types you can choose from when you invoke a repository finder method, and we're going to have a look at those. And let's start with iterables, because this is the type that we're using in the CRUD repository, right? So there is, if you bring in CRUD repository, then there is a method that says iterable find all. And yes, iterables are great in terms of interoperability, because you can override the method signature with pretty much anything, but they're not so great to work with, because underneath, typically, the data stores will give you something like a list. So you have all the memory implications, so you have everything in memory, but you will only see the one item that you request with next. And there have been several requests to actually change the method signature of the CRUD repository to return a list instead of iterables. And we had discussions within the team, because this would very much limit what the signature, you wouldn't be able to override the signature as easily as you can now. That's also the reason why we introduced those separate interfaces like list CRUD repository. All right. List obviously gives you more insight into your data. So if you define your method to just return a list, then everything is loaded into memory. You can ask it the size of the things, and you can do additional filtering, like using the Stream API. I guess pretty much everybody already knows the famous find all method that CRUD repository has, and then people calling Stream on it, and then filter and do stuff. And yes, you can do so. You can also put ghost pepper on your skewer, and yeah, you just shouldn't complain if it's really hot when you eat it. Right, so you can do it, doesn't necessarily mean that you should do it. Nevertheless, returning lists has a lot of benefit because, as I mentioned before, stores will give you a list, so it's in memory anyways, and just make sure that maybe the amount of data that you're loading isn't too big. Like in my example, getting the all orders for a specific customer might just blow up your memory or slow down your machine. So an alternative could be to use a stream directly. So this is specific to the database that you choose and the persistence technology and the driver that you're using. So you could also have a stream all method, which is perfectly fine. It will just utilize the driver's capabilities and give you the results one by one, with the additional memory benefits that it just loads, that it doesn't load a bunch of entries upfront into memory, which is very nice. And you can still use the streaming API to do some additional filtering if you want to. Right. A little bit more advanced are things that give you additional insight into your data, and this is the slice return type. A slice is basically, you can think of it as a container for the results. The results will be within the list internally, but it will tell you if there's more data available. And the way we do it is you request an amount of n items, and we'll request for you +1, and skip that one in the result just to know if there's more data available. So it's pretty much a sneak peek. Hey, is there more data? Can I have more? Without actually having to count upfront how many items a query would return, which is something that the page does. So when you're using a page type, and I know that's really handy if you have huge amounts of data and you want to go over them chunk by chunk, and do some pagination on the UI, then it's really nice to get this page container that tells you, I have a next page, I have a previous page, I have 10,000 items for this query that you could potentially look into, but this has a cost, right? And the cost is that we have to run an additional query to just find out, hey, is there more data available, or explicitly how many hits did we score? And depending on the persistence technology you're using, can be more expensive, like for SQL stores, pretty expensive. For things like Elasticsearch, it's part of the Elasticsearch API anyways, so it doesn't come at an additional cost. So you really have to think about what technology you're using. And the last thing I want to go about over here is the window skewer, which is pretty new to the Spring Data family. Just quick show of hands. Anyone using window? No one? Heard of it already? Yes, 1, 2, right. Great. So a window is like, you can think of it like a specialized slice. So it has the very same characteristics. So it loads a specific chunk of data, asks +1 to find out if there is more, maybe, but it has 2 incarnations. And the first incarnation is you can use a window with an offset to just move along the window like you would with a position, and with the offset you say start at position 0 and give me 10 items, and you get the first 10. Or you say start at position 3 or after position 2, and you will get the next chunk. So it's pretty similar to a page and a slice, but still it's sort of a different concept. And the other thing that you can do with it is you can do keyset pagination. Like if you think about the offset one, that one is great with the skip and the query that you run. But the deeper you go into your data. The database just basically the cursor selects everything, and then it goes from here to there, skips all this, ditches it, and returns you this part. And the further you go, the longer this will take. Of course, databases are smart. You're using indexes and shortcuts and stuff like that. So but it's a known problem in some regards. So what you can do is you can use a keyset to indicate where you want to start reading from. And this is also not something really new. This has been around for I don't know, 10 plus years. There's people talking about this, like Markus Wienand. He's a colleague in Austria. He's been advocating for this for years already on his blog. So the idea is that you use a stable sort expression, like you need to have a stable sort, and then use all the values that you find in the sort and combine them with the last result that you have, so that you can then create a combination of and or criteria to tell the database to just start after a specific or at a specific element and read from there. So the database always starts returning the entries that it finds at row 0 and doesn't have to skip anything. And depending on how many criteria you have, this may work worse or better, but theoretically, once the database is smart enough and the indexes are set up correctly, this should be pretty fast if you're doing deep pagination. Right, and that's also something that you may want to consider if you're crafting APIs like with GraphQL, where you can have different scrolling criterias and offsets, and that's actually what Spring GraphQL is using to talk to Spring Data Repository implementations. So this is a quick overview, basically about what I just told you, the ups and downs of the different return types that you have. We didn't talk about Flux because the reactive part is a different story. Still, for completeness, the Flux is just using whatever you request and then just give you that amount of data, and it's using the offset scrolling strategy. All right, there's one thing I forgot to show you, which I want to do right now. Then this is the going back to how you could extend your repositories. There's one thing that came to my mind yesterday when listening to Jürgen's keynote with the add primary annotation. Like, you could do just for tests, like you don't want to have delete method, but if you have want to have a delete in your test, then you can just go over here, add some repository just within your test scope, and then add the delete method and extend the order repository. You just have to make sure to mark it as a primary bean, otherwise there'd be two beans of order repository and the order management would get confused. But still, you can do this, and so you don't have to go in your test and do entity manager, delete, blah, blah, yada, yada. You can also use the repository for this. Just something I forgot earlier. All right, moving on. What can we do with our data? I personally, I love burgers, and also my kids love them, but I wouldn't want to have a burger without onions. While my kids are like, onions? Seriously? Ugh. Yes, and they open it up and pull them out every time. And so in Spring Data we have also this option to just pick and choose what to return from the underlying store. And if we look at our order and consider this the full-blown burger, the experience that has everything like the onions, and we just want to convert it into a smaller incarnation of itself, we could want to do this just because the overview that we're trying to create doesn't care about, let's say, the actual line items that are contained in the order. It just cares about the status of the order, maybe, and the order ID. So in just having this very specialized view, we can gain some performance, just because we don't have to do certain joins. We don't have to load that many data. It's more secure because data that's not present cannot be exploited, like customers and stuff like that. So, and there's 2 ways, actually 3 ways we can achieve this. And one way is we can use just simple Java classes like a DTO. This is what in Spring Data we call DTO projections. I think Torben called them in yesterday's talk slightly differently, and he's been using records, which is perfectly fine. You can use records all along. Those don't need to be managed entities. It's just a view onto your data. All you have to make sure is that more or less what you have in there, that the properties just match what you have in your domain types in terms of the field names, so that the persistence provider can fit them together. Sometimes they also need a little help, like for JPA, if you're using records, then everything is fine because we can find the right constructor. If you're using something like a class that has a protected constructor and then an additional one, then JPA cannot find out which one to choose to instantiate the view. So you have to have this little hint in here, that we can tell JPA use this constructor and be done with it. If you're using records, it's all fine, just this one constructor. And if you do so, we're gonna alter the select statement, obviously, to just skip out anything that's not needed and return that to you. And another alternative, oh yeah, and you can obviously just use it and return it. The other alternative is like you can use interfaces, which is slightly different. So all you have to do is make sure that the method signatures for the getter methods match, and then we'll just use tuples or maps or what have you, depending on the store implementation, to just back the interface, create a proxy for you, and then on the invocation. Again, since we know the properties, because you explicitly defined them there, we can also trim the select statement for any data store to just those properties and only load that amount of data. Of course, you can nest projections, so you can do a projection in a projection, like for the line item. You could also project that one, but this has some implications, and depending on the store implementation, it will turn something like this. These are closed projections into an open projection where we have to load everything, because the select statement would get overcomplicated, or just because we don't know which parts you actually need, which is the same as with something that we call open projections, and those are the ones where we don't know upfront which values you would want to retrieve from the data store. Like you could use the add value annotation and then use a spell expression to target the values in there. This goes even so far that you can use registered beans and call methods on them, like here. So if you have a component that's called overview helper that has this items method, then you can directly invoke this component from your interface projection. Of course, this has a price, because we don't know what you're going to do. So we have to fetch the full-blown burger and then just pass it down, and so you'll lose the performance gain. It still will be secure, more or less, because the outside world will not be able to access the data loaded. Still, it comes at a price. All right. Yeah. We've got custom conversions for selected data stores, of course. Mainly entity converters, like you could go from a burger with a beans patty into something that uses an Oreo. I've never tried this before. If anyone has done this, please come to talk to me afterwards. I'd really be interested how that tastes. Anyways, what you'd need there, these are entity converters, so they're based on a type, like the order status. And whenever we see a status coming in, then we're gonna on write to the data store, we're going to call the converter, and of course we wanna be symmetric, so we have to also have a reading converter. These are very, very, I don't know, noisy APIs, like all these annotations and stuff. You can shortcut this. There is something, I don't even know if it's documented, but it's in there, definitely. It's converter aware, and it has a converter builder, and it gives you this nice fluent API. And it's way shorter than the full-blown classes, and it will do just the very same stuff. All right, sometimes you don't want to convert each and every status into something else, like you want to be specific which properties you would want to apply a converter to. It's like attribute converters, if you're familiar with JPA. And for selected data stores, we support something called property converters, and they work pretty much the same way, but you just put an annotation on a certain property, and instead of converting each and every status, we just convert those with the annotation there. The API is slightly different, only slightly, because we want to give you more context. Like for MongoDB, there is this Mongo value converter, and it gives you a Mongo conversion context, so that you always know in which part are you actually, because you could have the converter annotated on multiple types potentially, and so you could ask it, is this the actual order, or is it something else? And then you could even go and call the default converter a conversion, or do something on your own. And you can also, and this is interesting, I think, combine the approaches into something more advanced, because through the context you can also look up other annotations on the property that might be there. And we're dogfooding this ourselves for MongoDB for the explicit encryption feature, where we just take an encryption converter and then encrypt reading, writing, converting your properties, and that's basically based on the encrypted annotation that we already have for data MongoDB, and it's a value converter, and down here it's a Mongo encryption converter. So you can compose your own annotations to just fit your needs, and then come up with really new things to do. Maybe encryption, maybe not, who knows. So gotta hurry up a bit. We've got data query for type-safe queries and fluent queries. Many times you see that there is string variants within your queries, and we all know strings are you get them wrong from time to time. There's typo in there, and then all of a sudden it doesn't work. So there's different strategies you can try to cope with that, and one is type-safe queries. So you could generate the static meta model from your JPA types and use those with the specifications that we saw before. You could also try something like query by example, where you create an example object, and then every non-null field will be used to find matches. Though I have to admit, this is a very, very limited approach, because for date values you won't be able to express any before or after. It just goes equal and similarity stuff. Still, it might be useful if you have some form that you pass down and looking for exact matches. And you can use third-party stuff like Query DSL, that is like an annotation processor, like the static meta model. It will create some Q classes like down here, and then you can just nicely go on and use the Query DSL API for your data store, and use the Query DSL predicate executor to bring it in. Just one word of caution: you cannot, in this case, you cannot just copy the method signature. That won't work, because it's an external dependency, and so the implementation is a little bit differently, and the wiring wouldn't work. otherwise. All right, but you can also use something that we added a couple of releases ago, is like fluent queries. This is comes in handy if you want to give the calling side more control over what they are fetching, like you have the repository for access, but you have something like a query DSL endpoint, not query DSL, GraphQL endpoint that tells you I want to fetch these and these properties, and I want to have 100 items and whatnot. And what you can do there is you have this a callback function with a fluent fetchable query. That's what we call it. And for JPA, you can give it, let's say, a specification for open orders, like we had before, and use that one. And then down in this callback, you get the query, and you can then decide which properties you want or how many items you would want to retrieve. So depending on how much you trust the calling side, this might be an option to craft something like a more open repository API, like you'd need for GraphQL, potentially. And the nice thing about GraphQL is that this independent model makes it a little bit more secure. Still, you have to trust it, because everyone calling all the time, yeah, we know where this leads to. It will burn your server pretty. All right, we got a few minutes, so let's talk about sides, like fries that you need to have with every burger. And one is like if you look at the repository definition like this, and you have a find by customer ID that returns an order, then typically what you'd get is null or the order, right? That's what you expect. Now, in Spring Data, we have support for JSR 305 nullability annotations, which help you with the tooling and stuff in your IDE and with Kotlin. But it also comes with repository implications, because if you add this to your package, then we'll recognize this, and if there is no result for the customer, then instead of null, we'll throw an empty result data exception, because this method is not supposed to return any null values. Just by adding this annotation, you'll get a different behavior out of your repository. And added in the latest edition of Spring Data, we finally have placeholder support within this kind of stuff. This has been an open issue for, I think, ages, but we finally managed to do it. So I apologize for not doing it earlier. Really, it should have been there from the very beginning. All right, I want to spend the last 2 minutes on runtime considerations, from the point of view of a data repository. Like we all know Graal VM already, and this closed word assumption and the build time implications. And from a data perspective, it sometimes may be necessary to help Graal VM and the application a bit for the types you need reflection for. Like there is store specific, like for MongoDB, we've got this managed types abstractions, and you can, by just registering this bean in tell Graal VM, please consider those types as well for reflection. We've got Crack with all its goodness and limitations, like the open sockets that you mustn't have for when taking the snapshot. And there is documented for the stores that we support the options that you need to set, like don't create anything, and for Hikari allow the pull suspension so that we can close the connections up front before taking the snapshot within the Spring Lifecycle model, and yada yada. Still, some vendors don't support shutting down the connections when the driver is created. So you might want to check out Spring Cloud and refresh scope, which is an annotation that creates a proxy around your resource, and then it can participate in a lifecycle if they spin up connections that you cannot close. And of course, CDS, very interesting stuff in there. Still, you potentially wouldn't want to connect to your database during the training run. So there is again some properties you might want to set, like for Spring Data JDBC, if you define the dialect upfront, we don't have to go ask the database. Right. We've got integration with Micrometer and Java Flight Recorder, obviously, so you can activate those. Like for MongoDB, it's like the Mongo Observation Command Listener, and yeah, JFR will just publish stuff and events and tag it correctly so that you can look it up if there are issues. Right. With that, this cookbook wouldn't have been possible without these guys and many, many more folks. Actually, there's lots of people. I want to thank everyone who contributed to any of the projects, may it be opening issues, asking for new features, stuff like that. Thank you for using the stuff. I hope you enjoyed the talk.